Hello, my name is Scott Cornelson. I'm with Campbell Scientific, and today we're going to be introducing and demonstrating our CDM VW300 Dynamic Vibrating Wire Analyzer. This is developed at CSI as part of our line of vibrating wire interface products. The technology in this device stems from what we developed for the AVW200 and extends that functionality into the dynamic applications. What makes the AVW200 unique is that it employs a spectral analysis algorithm to measure the resonant frequency of the gauge. This is different than the traditional methods of measuring vibrating wire gauges, which use a time domain method. The benefit of doing this is that it provides excellent precision, which is orders of magnitude better than the time domain method. Another benefit is that it is more robust to the influence of external noise, because the device is able to discriminate between signal and noise based on the frequency content of the signal. The CDM VW300 builds on the spectral analysis algorithms developed for the AVW200. The difference between these two devices is the speed at which they can make their measurements. The CDM VW300 can make measurements ranging from 20 Hz to 333 Hz. These rates are well suited for measuring dynamic, structural, and geotechnical processes. The CDM VW300 is able to make dynamic measurements by maintaining the vibrating wire in a continuously vibrating state. At the beginning of each data logger scan, the analyzer provides a short duration, low voltage excitation pulse that is phase aligned to the motion of the wire. This pulse adds constructively to the energy in the wire and sustains its motion. It is important to note that the excitation is inserted according to the time base of the data logger and is independent of the frequency or phase of the wire. This allows us to synchronize all of the measurement channels to one another and to the scan of the data logger. It also ensures that the excitation pulse is not included in the digitized sample used for determining the resonant frequency. To demonstrate the operation of the CDM VW300, we'll be using a Geocon Model 4202 concrete embedment gauge. This gauge is designed to measure the compression strain in a block of concrete. The nominal resonant frequency of this gauge is approximately 2.5 kHz. We have installed one of these gauges in a small pillar of concrete. The pillar is about 7.5 inches across and 14 inches tall. The gauge is oriented vertically in the pillar. For this demonstration, we are sampling the gauge at 50 Hz, which has a noise level of approximately 15 mHz RMS. For this gauge, 15 mHz equates to approximately 25 nanostrain of noise. Given the geometry of this pillar, 25 nanostrain corresponds to roughly 10 nanometers of compression. Now let's look at the data streaming from the CDM VW300. The data is streaming directly to the PC via the USB port on the device. The program that is reading and displaying this data is DVW Toolbox. This is a free, application-specific software tool designed for demonstration and evaluation of the dynamic vibrating wire interface. The vertical units on this graph are in microstrain, and the graph is scaled to show 4 microstrain overall. I will now stand on the pillar and jump several times and collect the data. With the graph paused, we can note several things. First, notice the frequency response of the gauge. All of the forces in each jump are easily captured, including the bending of my knees, the push-off, the airtime, the landing, and again the bending in my knees. Next, notice the flat regions at the center of each jump. This is where my feet actually leave the surface and the gauge returns to zero very precisely. This is one of the great benefits of vibrating wire gauges. Their stability can be seen here. Lastly, notice the amplitude resolution. The full amplitude of the strain is only 2 or 3 microstrain, but the signal-to-noise ratio is excellent. I hope you've enjoyed our demonstration to show some of the capabilities of the Dynamic Vibrating Wire Analyzer. This new device opens the door for an entirely new category of measurements for vibrating wire gauges. We look forward to exploring the many new applications where this can be used.